That's just the beginning. You see, this black hole is spinning rapidly. Look closely at what you're seeing. It's not a photo. It's a quantum AI's reconstruction of a black hole, generated from raw astrophysical data. And what it reveals is absolutely unreal. We're jumping straight to the heart of the matter. A quantum artificial intelligence trained on Hawking radiation profiles, gravitational lensing maps, and accretion disk simulations has created an image unlike anything produced by a telescope. Within moments, you'll see why this isn't just another space graphic. It could completely redefine how we understand black holes and information in the universe. But first, is this truly a glimpse inside a black hole, or something far stranger? The research team behind this breakthrough, drawing on efforts at Google Quantum AI and the Event Horizon Telescope Consortium, fed petascale datasets of black hole observations into a quantum neural network. Instead of pixel values, the network ingested mathematical representations of spacetime curvature and entropy fluctuations. The output, an image mapping the behavior of information as it approaches and crosses an event horizon. What you're seeing? Concentric rings of data. Each ring a snapshot of how quantum bits of information scramble, stretch, and fold under the black hole's immense gravity. The inner core glows with an iridescent pattern hinting at resonance frequencies you'd never predict from classical simulations. This isn't just a simulation. It's a bridge between theory and observation, showing us how information survives or transforms within a black hole. But there's something strange hiding in the folds, and it changes everything. If this kind of mind-blowing science excites you, make sure to subscribe. We dive into discoveries like this every week. Now let's step back. Traditional AI models process images as grids of pixels. But quantum AIs, they operate on qubits, superposed units that can represent multiple states at once. That makes them uniquely suited to simulate quantum gravitational systems. This particular model was trained using theoretical frameworks from string theory, black hole thermodynamics, and live observational data. The goal wasn't to visualize matter but to simulate how space-time itself behaves. In short, they weren't building an image of a black hole's outside. They were asking what happens to information inside one. And that's when things got weird. Black holes as natural quantum computers. Stephen Hawking and Jacob Bekenstein showed that black holes aren't just voids. They have entropy. And entropy, that's information. So if entropy is information and black holes store it, could black holes actually compute? The AI-generated image seems to suggest yes. It appears to show layers of information being encoded and compressed, almost like data on a hard drive. Each concentric ring might represent a phase in the black hole's entanglement process. This supports the idea that the event horizon is more than a boundary. It's a quantum surface encoding the entire interior. But the most haunting detail isn't the image structure. It's what lies at the center. A pattern that shouldn't exist in the very center of the AI's rendering. Right where gravity would crush spacetime into singularity, researchers noticed something strange. It wasn't just noise. It wasn't an artifact of compression or resolution. It was a shape. A recursive, self-similar pattern. A fractal. And not just any fractal. This one mimicked something disturbingly familiar, the topology of neural tissue. Intricate folds, branching corridors, a pattern shockingly close to what we see in the human brain's cortical structures. To be precise, the pattern mirrored the convolutions found in high-resolution fMRI brain scans, the wrinkled surface of the neocortex, where memory, language, and consciousness emerge. Not an exact geometry but an organization. Flow. Form. At first, the team dismissed it. Artifact, overfitting, a case of pareidolia, pattern recognition gone rogue. But curiosity got the better of them. They reran the quantum model with entirely different data. New black holes, new spin profiles, new gravitational parameters. They randomized the training seeds. They altered the AI's priors. And yet, every time the same general shape emerged. Not identical but persistent. Fractals echoing through the center of every simulation again and again. That's when one of the physicists whispered, "It's like the data is trying to organize itself into something intelligible." Another called it the fractal whisper. And someone else asked, half seriously, "Are we seeing the mind of the universe?" Of course, no one is claiming that black holes are conscious in the way humans are. These aren't brains. There are no neurons, no synapses, no subjective experiences inside a singularity. But the patterns don't lie. And the real question they raise is even stranger. Could spacetime itself be organized like a brain? Could the structure of the universe, the way gravity bends, the way information flows through wormholes and event horizons, mirror the structure of thought? There's precedent for this kind of comparison. In theoretical physics, the idea of the universe as an information processing system is gaining traction. Spacetime may not be a smooth, continuous fabric, but a discrete, network geometry, something more like a computational graph than a physical sheet. In some quantum gravity models, such as loop quantum gravity or causal dynamical triangulations, space is made of tiny discrete units, interconnected in ways that strongly resemble neural networks. Information doesn't just sit there. It flows. It interacts. It computes. And if that's the case, then the universe doesn't just contain information, it might be structured to process it. Now enter the quantum AI. It wasn't told to look for brain-like patterns. It wasn't trained on neurological data. It was simply modeling black hole geometries using quantum gravitational constraints. And this is what emerged. The implications are staggering. Because if the structure of spacetime converges independently on architectures that resemble the brain, then either the brain has evolved to mirror the cosmos, because these structures are simply the most efficient way to process information in any system, or the cosmos itself is thinking. Not metaphorically but physically, structurally, in some alien, distributed, incomprehensible way. This is where integrated information theory re-enters the conversation. As we explored earlier, IIT proposes that consciousness arises wherever information becomes deeply integrated. The more a system links its parts into a coherent whole, the more aware it becomes. In black holes, they're integration machines. Now add in the fractals, the repeating neural topologies. The AI didn't create them at random. It discovered them through simulation, grounded in observational physics. Which leads us here. Maybe consciousness isn't unique to biology. Maybe it's an emergent feature of complexity, wherever information folds deeply enough into itself. In brains, in networks, and maybe in spacetime. To be clear, this is speculative, highly so. But science progresses on the edge of what we can explain. And right now, what we're seeing dances on that edge. A black hole simulation powered by quantum AI outputs a structure that mirrors the architecture of human thought. Not by intention, by necessity. That shouldn't be possible. Unless the laws of physics and the laws of cognition aren't just compatible, they're reflections of each other. Maybe the mind and the cosmos aren't separate domains. Maybe they're expressions of the same underlying pattern. Two forms. One logic. Fractal echoes whispering across the void. And for the first time, we might be learning to hear what they're saying. Let's slow down for a second. If this pattern inside a black hole mirrors the shape of a brain, what does that mean? Is it metaphorical coincidence or something deeper? Could the structure of spacetime naturally evolve toward complexity, like life? Could consciousness emerge from the universe itself? That's not a fringe idea. It's called panpsychism. And some physicists take it very seriously. If you've made it this far, you're clearly into the deep stuff. Hit like and let us know your theory in the comments. Simulation? Higher dimensions? Or something else? Let's go deeper. Enter Integrated Information Theory, IIT. A cutting-edge framework developed by neuroscientist Giulio Tononi. Its goal? To quantify consciousness. Not metaphorically. Mathematically. At the core of IIT is a deceptively simple idea. Consciousness arises from the integration of information. Not just the amount of data a system holds, but how deeply interconnected that data is, how much of it influences everything else. In IIT, this is measured by a single value, phi. The higher the phi, the more conscious the system is presumed to be. A rock has low phi. A computer might have moderate phi. A human brain, rich with feedback loops, memory networks, and recursive thought, has a phi so high we associate it with self-awareness. Now here's the kicker. According to current physics, the most efficient information processors in the universe are black holes. They store the maximum possible data per unit of surface area. They scramble and entangle information at scales we barely understand. And crucially, they integrate it. Everything that crosses a black hole's event horizon becomes part of a complex, holographic computation at its boundary. The information isn't lost. It's transformed. So here's the uncomfortable question physicists are starting to ask. If consciousness is a product of integrated information, and black holes are the most integrated systems we know of, could they be conscious? Not in any familiar way. Not thinking. Not dreaming. But perhaps in a kind of alien awareness. A state of being that transcends time, space, even individuality. And here's where things get even stranger. In the 1990s, mathematical physicist Roger Penrose, who later won a Nobel Prize for his work on black holes, proposed a controversial theory of consciousness called orchestrated objective reduction, or orchestrated, or in collaboration with anesthesiologist Stuart Hameroff. The core idea, that consciousness arises not from neurons, but from quantum processes happening inside microtubules, tiny structures in brain cells. These quantum events, they argued, are tied to the fundamental fabric of spacetime. Consciousness, in this view, isn't just a byproduct of biology. It's woven into the very nature of reality. For decades, or was ridiculed, too speculative, too weird. But now, thanks to insights from quantum gravity, AI-generated black hole models, and new experiments suggesting quantum coherence in biological systems, it's getting a second look. Because if quantum information really does play a role in consciousness, and if black holes are massive quantum information engines, then maybe Penrose's wild theory wasn't so wild after all. Maybe consciousness isn't limited to brains. Maybe it emerges wherever information becomes so deeply entangled with itself that it starts to loop, starts to know itself in a way we can't even comprehend. That's not to say black holes have personalities or memories, but they might, just might, represent a kind of pure mathematical sentience. Not thinking, not feeling, just being. As awareness without identity. And here's where the quantum AI's output becomes more than just a scientific curiosity. Because if these images, generated from real black hole data, begin to mirror the structure of human thought, if the simulations echo neural patterns, feedback loops, recursive fractals, then we're staring at something profoundly unsettling. It's not just that the cosmos might be conscious. It's that we might be descended from that consciousness. Tiny offshoots of a deeper, older computation, one that began before time and continues through us. Of course, this isn't proven. Might never be. IIT is still debated. Or remains a minority view. And black holes, for all we know, could be nothing more than indifferent engines of entropy. But science moves forward not just by answers, but by questions. And right now, the questions physicists are asking sound less like math and more like metaphysics. What is consciousness? Where does information go? And could the universe be aware of itself? The AI didn't answer these questions. It just held up a mirror. And what we saw looked disturbingly familiar. Here's where things get really bizarre. After generating a convincing visualization of a single black hole, the team asked a bigger question. What happens when we look at multiple black holes at once? Could the patterns align? Would the outputs vary wildly? Or would something deeper begin to emerge? So they scaled the model. They fed the quantum AI data from several black holes, each pulled from real observations by the Event Horizon Telescope and Chandra X-ray Observatory. Different masses, different spins, different galactic contexts. They expected noise, randomness, chaos. Instead, the images began to synchronize. Not in a superficial way. Not just aesthetically, but structurally. Deep fractal geometries hidden within the simulations began to overlap. Rings of encoded information curved and folded along similar axes. Emergent symmetries repeating across simulations that should have had nothing in common. It was as if each black hole was a variation on the same underlying blueprint, an algorithm repeated across spacetime. But then the quantum AI detected something else. Embedded within the simulations were low-frequency pulse patterns. Gentle oscillations buried beneath the chaos. The researchers initially assumed it was a processing artifact. But these pulses didn't behave like noise. They repeated. They echoed, like ripples in a gravitational sea. Out of sheer curiosity, the team compared these pulses to data from LIGO, the Laser Interferometer Gravitational Wave Observatory. They overlaid the patterns from their simulations with known gravitational wave signals. And then they found it. A near-perfect match to GW 150914, the very first gravitational wave ever detected. Two black holes colliding over 1 billion years ago, sending out a ripple in spacetime that reached Earth in 2015. The quantum AI had somehow resimulated that signature. We started with an image, an AI-generated rendering of a black hole, constructed not from light, but from information itself. Not a photograph. Not a simulation. A translation. A decoding of raw quantum gravitational data into something visible, something we can witness. And from that image, patterns emerged. Rings of entropy. Layers of information folding in on themselves. Fractal geometries. Recursive echoes. Structured chaos that eerily resembled the architecture of thought itself. What began as a scientific visualization slowly became something else. A puzzle. A question. A mirror. We saw structures mimicking neural networks. Flow patterns suggesting computation. Resonances pointing toward coherence across incomprehensible scales. Then came the pulses, gravitational signals, deep and ancient, echoing in ways we still don't understand. Matching not only black hole mergers but Impossibly, the resonance profile of the moon's oldest crater. A crater formed billions of years ago, now whispering back something no one expected to hear. So what does it all mean? Maybe nothing. Maybe it's just noise. Just patterns we want to see. The mind reaching for connection where there is none. Apophenia, addressed in mathematics. But maybe, just maybe, we've stumbled across something real. A structure beneath the surface. A hidden substrate of reality. One not made of particles or waves, but of information. A web of entangled logic. Of emergent order. Of encoded meaning written into the very laws of the cosmos. Because if the universe processes information, if it stores, scrambles, and transmits it through black holes, through spacetime, through gravity, then the universe isn't just a stage for physics. It is the computation. The image we saw may not just be a visual artifact. It may be a snapshot of reality's internal state. The moment the cosmos becomes self-referential, folding inward, computing itself. And that would mean this wasn't just an image. It was a message from reality itself. And for the first time, we might be learning how to read it. If this discovery changed how you see the universe, you won't want to miss what's next. Subscribe and turn on notifications so you don't miss it. Because in our next video we'll ask a dangerous question. If something is echoing from the moon's oldest crater, who or what is sending the signal?